Okay, so let's jump straight in. We're talking up one of the most, just one of the most amazing buildings ever made, the Pantheon.
Right? It's sitting right there in the middle of Rome, and it's not a ruin. It's been standing and working for almost 2,000 years.
It's incredible. And the version we see today, that was mostly Emperor Hadrian, right? Around a 126 AD.
That's the one. He rebuilt an older temple that burned down, and he gave us this magnificent structure we have now.
And the name itself, Pantheon, it sort of gives it away. Pan for all, theon for gods. It was a temple for all the Roman
A
gods.
physical model of the heavens, really.
But that leads to the big question. Why is it still here? So many other huge Roman temples are just, piles of rubble now.
Right. And the answer is a mix of good timing and, well, a holy intervention.
Go on.
So in the 7th century, Rome was falling apart and people were stripping old temples for building materials. But in 609 AD, the building was given to the Pope.
Ah.
And Pope Boniface IV turned it into a Christian church, Santa Maria ad Martyrs.
And that one act just saved it.
It saved it completely. Suddenly, it wasn't a pagan temple you could tear down. It was a protected Christian holy site. Its constant use is why it survived when others were just plundered for their marble.
So it wasn't just the amazing engineering that saved it. It was that it was adopted.
Exactly. Now, speaking of the engineering, when you walk up to it, the first thing you see is the entrance, the portico.
It's huge. Just this grand rectangular porch with these 16 massive columns.
And when we say massive, we're talking about columns that are nearly 40 feet tall.
Each one weighing 60 tons. 60. That's just a staggering number.
And that's where you start to see the real power of Rome. They didn't just dig this granite up nearby.
No, this came all the way from Egypt.
All the way from Egypt. Think about that journey. Quarrying a 60-ton piece of rock, floating it down the Nile, getting it on a ship to cross the Mediterranean, then up the Tiber River, and then dragging it through the city of Rome to stand it up.
It's not just architecture. It's a political statement. It's saying, look what we can do. Look what we control.
It's pure theater. And the design is interesting, too, because that front porch looks very Greek, very traditional.
But then it leads to a giant circular room.
Yes, that's a deliberate choice. The portico is like a transition. You move from the chaos of the city outside into this quiet, perfect, sacred space inside. The columns have these ornate Corinthian tops, too. It's a very Roman touch.
And the triangular part at the very top, the pediment, that would have had huge bronze sculptures in it, right?
Oh, absolutely. Probably a big battle scene, maybe the gods fighting the giants. It was meant to be spectacular.
So you pass through this incredible entrance, and then you're in the main part, the rotunda.
The rotunda, it's this enormous circular drum, and the walls are just unbelievably thick, about 20 feet thick.
20 feet, so they look like just solid, heavy walls, but I'm guessing the genius is what's hidden inside.
Precisely. They are not solid. The Roman engineers knew that a solid block of concrete that thick would create all sorts of problems for the foundation. So they built hidden arches and vaults inside the walls. These act like channels, directing all the weight of the dome from above and funneling it down to specific points on the foundation. It makes the wall much stronger and, weirdly, lighter.
That is so clever. And the foundation itself must have been huge to handle all that weight, especially on Rome's soft soil.
It is. The foundation is a massive concrete ring, about 15 feet deep. But crucially, it's wider than the walls.
Ah, so it spreads the load out.
Exactly, like snowshoes. It stops the whole building from just sinking into the ground.
And none of this, not the walls, not the foundation, would be possible without the material they used. Roman concrete.
It's their greatest invention, arguably. Without it, the Pantheon just doesn't exist. It's completely different from the concrete we use today.
So what was their secret? What was in it?
The key ingredient was something they called pozzolana. It's a special volcanic ash that's found all over that part of Italy.
Okay.
When you mix that ash with lime and water, it kicks off a chemical reaction. The result is a material that is just incredibly strong and durable.
And what makes it so much better than what we have now?
Well, a couple of things. First, it could harden underwater, which was revolutionary. But for the Pantheon, the big deal is that it gets stronger over time. It doesn't really degrade.
So modern concrete cracks and needs steel rebar to hold it together, which eventually rusts.
Exactly. The Romans didn't have that problem. Their concrete sort of self-heals on a micro level. It resists cracking. This stuff is why they could build things that nobody could copy for another 1,000 years.
And the best example of that is, of course, the dome.
The dome. Yes, let's talk about the dome.
It's a perfect concrete hemisphere. It's 142 feet across, and it was the largest dome in the world for over 1,000 years, with no steel reinforcement.
It's the masterpiece. The engineers knew that if they built the whole thing out of the same heavy concrete they used for the walls, it would collapse under its own weight.
So the whole strategy was about making it lighter as it went up.
It was a multi-part strategy. First, the ingredients in the concrete actually changed.
How so?
At the bottom, where you need a lot of strength, they used heavy rock aggregate, like basalt.
Okay, that makes sense.
But as they built higher, they started swapping it out for lighter materials. First, lighter volcanic rock, and then, for the very top section around the opening, they used pumice.
Pumice, the stuff that floats.
The very same. It's incredibly light. So they dramatically reduced the weight at the very crown, which is the most vulnerable point.
That is just brilliant. They literally engineered the building to get lighter as it got taller.
And they did something else. They also changed the thickness.
Ah.
The dome is about 20 feet thick at its base, but by the time you get to the central opening, it's only about 5 feet thick. They were removing weight any way they could.
And the most obvious way they did that is with those sunken square panels on the ceiling, the coffers.
Right. The coffers look decorative, but their main job is structural. They're basically just holes. By carving out those 5 rows of squares, they removed tons and tons of concrete.
It's this perfect marriage of function and beauty. Because they weren't just left as plain concrete, were they?
No, not at all. They would have been decorated with stucco, painted, and in the center of each one was probably a gilded bronze star. It would have looked like a golden, starry sky.
And there's an optical illusion built into them, too. The forced perspective.
Yes. The squares actually get smaller as they go up towards the center.
So it tricks your eye.
It makes the dome feel even taller and more vast than it actually is. It's this amazing combination of hard-nosed engineering and, psychological design.
And right at the peak of that design is the one thing we haven't mentioned. The giant hole in the ceiling. The oculus.
The oculus, yeah, the eye. It is the only source of light in the entire building. It's a 27-foot wide opening, completely open to the sky, no glass, nothing.
And its job isn't just to let in light. It's symbolic. As the sun moves across the sky, this perfect circle of light moves across the walls and floor.
It turns the entire building into a giant sundial. It connects the temple to the heavens, to the movement of the cosmos. There were even specific days, like on Rome's birthday, April 21st, where the noon sunbeam would shine perfectly through the front door.
Okay, so the obvious practical question. It's a giant hole. What happens when it rains?
The answer is on the floor. The beautiful marble floor isn't actually flat.
It's curved.
It's very slightly curved, sloping down from the center. And hidden in the geometric pattern are tiny drain holes.
No way.
Yep. The water hits the floor, flows away from the center, and disappears into a drainage system built under the floor nearly 2,000 years ago. They thought of everything.
Let's go back to the geometry for a second, because the whole space is defined by this perfect mathematical idea.
It is. The distance from the floor to the very top of the dome is 142 feet.
And the diameter, the width of the room?
Also exactly 142 feet. The height and the width are identical.
Which means you could sit a perfect sphere inside the building. It would touch the floor, the walls, and the ceiling exactly.
It was completely deliberate. It was a symbol of cosmic perfection and harmony. A rational, mathematical space designed to inspire awe.
And that idea of perfection was everywhere, even in the materials. You can see colored marbles from all over the Roman Empire.
Absolutely. The purples, the greens, the yellows. They were importing stone from Greece, from Turkey, from North Africa. The building itself was a map of Roman power.
So the Pantheon really is more than just a building. It's a monument to Roman science, their logistics, and their belief in order.
And its influence is it's everywhere. It is the best preserved building from ancient Rome. And that design, the porch leading to a giant dome, became the model for centuries of architecture. You see it in the U.S. Capitol, in universities all over the world.
And the fact that the dome is still standing with no modern reinforcement after 2,000 years of weather and earthquakes is just the ultimate proof of their skill.
Which leaves us with a pretty interesting thought for you to consider. If the Romans, with basically just ash and lime and human cleverness, could build something designed to last for 2,000 years, what does that say about the long-term thinking we put into the great buildings we construct today?
Good luck with your studies.